I think time is there, so you may start.
Okay, thank you, sir.
Yeah, so let me share my presentation.
Yes, sir.
Okay, can you see it?
Sir, please open the chat window also, sir, so that you
Alright.
participants can interact with you.
Yeah, that's
Please.
right. The chat
Ji.
window should be.
Sir, in the top menu, on the sharing menu, there is an option of chat, fifth option.
Okay. And just choose everyone.
Got it, sir?
Yeah, I got it. Yes.
So should I start, sir?
Yeah, please. You
Okay.
can start.
Thank you, sir.
Thank you.
Very good afternoon to all. Hope you all had a wonderful lunch at your home. Today we have privilege to have Professor Ibrahima Faye sir with us. Presently, Ibrahim Faye is currently as an associate professor at University Technologia Petrona, Sri Iskandar, Malaysia. He is associated with the Department of Fundamental and Applied Science and the Center for Intelligent Signal and Imaging Research. He received a BSc, MSc, and PhD in mathematics from University of Toulouse and MS in Engineering of Medical and Biotechnological Data from École Centrale Paris. His research area includes signal and image processing, pattern recognition, and engineering mathematics. He is associated with the IEEE as a senior member, and he has a good profile as the Google Scholar Citations and the H Index. It is great privilege to have you. I heartily welcome you all and sir at Bharati Vidyapeeth Institute of Computer Applications and Management, sir. Today, sir will enlightening us on very interesting topic that is need of an hour, detection of student interest in the classroom. Now I request sir to please take over the session and enlightening us. Thank you, sir.
Thank you. Thank you so much. Thank you for having me for this program. So the title, as mentioned by to Vijay, that it's the detection of student interest in classroom. So I would highlight over here the work we have been doing because one of my interests actually is the science of learning. So we all somehow are involved in learning in any other way, any way. Sorry, but we need to see what we could do in terms of improvement. There are always ways of improving our way of teaching. So, okay, this is the overview. After the introduction, I will be talking about what is interest in learning, and what is EEG, the electroencephalogram for detection of interest. And this is where I will present actually the work that we have been doing in this section. Then what are the possible ways for the future? What are the ways of improving our work or trying different ways of improving the work that we have done? And then I will conclude this presentation. Now, let's start with just a basic definition. What is learning? Okay, I just take a simple definition. So acquisition of knowledge or skills through study, experience, or being taught. So you may find some of the definitions a bit more lengthy, but at the end of the day, we are talking about acquiring some knowledge, okay, by different ways. But we need to let's say take this basic of this basic definition. Now, people have been working in this area, especially in psychology, looking at ways of improving the learning, or let's say teaching and learning. So I've been working on looking at what are the potential objects, or let's say terms or facts that could impact the learning. So for example, talk about the emotions. So when some people are in different states in terms of emotions, what is the state in terms of learning? What is the impact? What is the influence of emotions in learning? For example, if you are very happy or you are somehow sad, are you learning better or learning a bit more? Learning will be a bit more difficult. Okay, so another way would be as well to look at attention. So if we have ways for checking what is the attention of our students, for example, can we find a correlation between attention and learning? That's something that we could quantify somehow. Then the understanding. So we would like to see how much people are understanding, because there's no point that if you teach, you finish your session, at the end of the day, no one in the class is getting what you are saying. So we would like to know if the students are understanding what you are saying. So what are the ways of checking these points? And the interest. So we'll see actually there are different ways of defining interest and different types of interest. But again, we want to see if this is something that will impact the learning or not. For example, if someone is not interested at all, can he still learn? Can we still do something for him to learn? So these are the ways that we need to analyze. And the last one that I have selected over here is the cognitive load. That means in terms of what is in the brain, how much is available, if I could say in that terms, because we have some limited capabilities at different levels. But if, for example, you are loading a lot of information to a student, there will be probably a time there he cannot take it anymore. I mean, nothing can go through because somehow saturation will happen. So we need to look at these things, because even, let's say, potentially the person is able to learn, but you are teaching him at a time where he is a bit saturated, then the knowledge may not go through. So these are the things that, especially the specialists in psychology have been working on. Okay, which is clear. That's great. Now let's just look at some of these tools. For example, emotions. What is the impact of positive and negative emotions on learning? So there are different results, different publications in this area, especially from people in psychology. Some claim that when you have positive emotions, then you are in a good mood to learn. But there are some other papers, some other research outcomes saying that actually if someone is in the negative emotions, he might be somehow alert. So he's ready to capture new information. Now, for example, what some teachers have been doing is you get the students, or let's say even kindergarten, because you don't have to get a lot of expressions. Just tell them every day when they come in, they have to tick one of these three. So this is just normal. In the right side, they are happy. And in the left side, they are sad. Now, based on this, they analyze and see what is happening over the day. How the students, the kids will be learning based on the emotion they are feeling at the early morning, if I could say. So different results, as I mentioned, but what could be somehow agreeable upon is that emotions will have an effect in the learning. So either it is increasing, decreasing, depending on how the experience is done, but definitely it will have some impact. Another term that have been used a lot in this area for learning is about attention. Okay? So there was, for example, recently just an article written in the Science of Learning. So we should pay more attention to attention. So the author was claiming many things in terms of learning, how impactful it is, in terms of attention, how impactful it is for learning. Okay, so for example, over here it say you learn something every day if you pay attention. Okay, this one could be as well understood that if the attention is there are ways probably to learn something. If no attention is there, the information is not going through. So definitely, knowledge would be something challenging to have. Okay, next one, the cognitive load. So as I mentioned, if you are loading your students with a lot of information, or you are teaching at a time where they are somehow already saturated, they might not be able to process any information that you give to them. So the knowledge may not be able to go through. So this is highlighted as well in different studies where people are looking at putting students in different conditions and then trying to see where will be the saturation point. That means where the students cannot capture anything new, because their brain is busy in so many things. Okay? So this one as well, we can understand that the level of load could have a big impact on the learning, and it could be, as you can see over here, it could be just on the spot. It could be as well on the long term. That means if the person is learning something in a condition where he is not really fully um, available in terms of memory, if I could say, in that sense, maybe he could capture something, but it may not go in the long term. That means for example, you assess the same person after a certain time, maybe the knowledge of that particular information will not be there anymore. So we have as well interest. That the many studies regarding the influences of interest in learning. Okay, so interest-based learning. So this is just an image where I want to illustrate that if the interest is not there, probably the learning could be difficult. There will be some challenges in the learning. And if the interest is there, how much it will help in terms of learning. After this as well, we have other ways of looking at it. That means if, for example, it's already proven, or let's say that interest will impact the learning, how can we make interest to happen? We'll see later on that there are two different types of interest. But at least if you are, for example, in the classroom on the spot, what should be the ways of having the students to be interested in what you are doing? Okay? These are things that we could look into and see how it will impact the learning of students. At the end of the day, whatever is the tool that we are bringing in, we want to somehow measure what is the output. The output, we have to make sure that the students, they understand what is the information that we are passing to them. Okay? So we should have ways of assessing and making sure that it's happening and the students are understanding what is taught. Okay, so that's for the introduction. I will talk about the interest in particular, because that was our attraction, if I could say, where we try to see how we could contribute in this area. Now, how it is defined, a process involving increasing attention, so is highly related to attention, concentration, and an increasing willingness to learn. Okay? So that is the main definition of interest. And then recalling main ideas independently of prior knowledge and intelligence. So that means, especially for the second point, if you are really interested, it would be easy somehow to recall what you have learned because you are, let's say, interested in that particular area. Now, the big challenge that we face, maybe it's not new, but many people have the same remark that now what is happening is that people learn most of the time in the right side, need to pass basis. They just need to pass the exam. The knowledge is there or not there is not a big issue. Many students will have this, unfortunately, this way of thinking. So right now, I just want to pass the paper. Later on, maybe I will have the knowledge. Okay? This is the opposite of the need of no basis. That means very few students probably would be in this area where they really have the interest for getting the knowledge in a particular field, for example. And what, for example, I used to say to students that if you are in this side, yes, you will most probably pass. Okay, you are having the interest, you are getting the knowledge, sorry, but with the knowledge, passing the exam will not be a big issue. The other way around, if you just want to pass maybe you have the knowledge on the spot. In the long run, it will not be there. And that's why sometimes when you teach, you see people who have good grades, but you see them the next semester, you ask them a question on something they obtain maybe A on that particular course. At the end, they cannot answer because they were not getting the knowledge. They were just working to pass the exam. That is some of the issues that we need to deal with lecturers, let's say. Now, I was mentioning that for interests, there are actually two types. The individual interest, which is somehow stable, motivational orientation that develops over time and is associated with positive feelings, increased knowledge, and value. So that means there are people, I just take the example of mathematics. Some people, they just like mathematics, let's say from day one, if I could say. They just like it. It rains, it doesn't rain, it is sunny, or it doesn't matter. They like it, whatever is the condition. Okay, so this is one type. This is, as mentioned over here, a bit more stable. In the other side, we have what the psychologists would call the situational interest. This is a focused attention and an attractive reaction that is triggered in the moment by environmental stimuli, which may or may not last over time. So what does it mean? Let's say you are in the condition of teaching. You have some students that are not really interested, for example, in the topic. Okay, but in a specific time interval, which is could be short, could be a bit longer, you present in a way that you attract their interest, because you mention something or you teach in a way that the interest is happening for this particular group of students. So as mentioned over here, that will be a situational interest, but that interest may not be in the long run. So it could be like 10 minutes, 15 minutes for this particular topic. You manage to get the attraction, so that they're focused, they are interested in what you are saying. So they may learn at that particular time, but it may not last in the long run. So, which means if you are able to find some subjects, or let's say some ways of bringing this situational interest to our students, that will be very good. That means we'll be able at least to, for particular intervals, to bring this situational interest where they could learn. Then definitely the other challenge would be how to maintain it. For example, if you have a class of 1 hour, it may not be easy to maintain the situational interest for 1 hour. So it could be like 15 minutes, then they might lose their concentration, then you need to get them back by doing something else. So this is like a continuous process. Now, people have studied interest and showed that actually, if you have some interest, for example, over here, we're just looking, just an example, it could be something else. We have interest in mathematics. There's some particular part of the brain that will be having different patterns, if I could say, pattern in terms of activation. Okay, so these are a few papers. I do not add them over here. They're in the references. So they show different places by doing different experiments and showing that the interest is related to these particular areas of the brain. So you will see later on why this is interesting. I mean, this is good for us because for what we want to do, we want to see later on, if we are using the electroencephalogram, the EEG, which part of the brain we need to concentrate for our signals, and which one we have to select and which one we have to process. Okay, so that's for the interest in learning. Now, the main work that I would like to present over here is the EEG for detection of interest. So why we go for EEG and what exactly we want to do with this in terms of practical applications. Okay, so just the for those who are not that familiar, electroencephalogram. So it uses the differences in voltage between two cerebral locations to plot a graphic representation of the brain activities over the time. So in short, we are just measuring the electricity that is flowing in the brain. So for example, if there's a particular part of the brain that is highly activated, you may have a voltage which is higher. So we can get the signal between different places. At the end, we can just have, depending on how many channels, which means how many places you are measuring, then you get different signals. Okay? So those signals will represent how the memory or how the brain is working. Then we have to do some process over these signals for different targets. Now, this, as mentioned over here, is probably the most used tool in computational emotional systems and human-computer interaction because of the cost, because that EEG is non-invasive. It's not considered as something harming the person wearing the cap. Relatively cheap compared to some other devices. So this is probably one of the motivation that brings people to use it a lot in different studies. Now, this is how it looks like. I mean, the signals, how they look like. So depending on the number of channels, you will have different signals. Okay, different where the caps were placed. So you get the signals, and then you have to do some pre-processing in general. You will have some noise, you remove all the noise, and then you have to process the data to get some information out of it. Okay, I have a message over here. Audio video lost. It's clear. Okay. Okay. So okay. So this is just the 1020 position. This is the standard places where the EEG will be placed. It is commonly used, and people can, I mean, in terms of expressing the results, it's easy to follow this 1020 position, which is the most commonly used. So we have, for example, the frontal part of the brain, you have the occipital, you have the frontal parietal, and so on. So we have different places, and definitely we'll have different kind of information coming from these places. Okay, now in terms of physiological sensors in interest research, we have actually a lot. There are a few. This is the EEG that I mentioned. This is just one of the caps that could be used. Okay, it's just something that you wear. We have the ECG, which is related to the cardiac system. We have the facial head and gestures, so that will be just recorded. And again, we try to see how we can use these signals, for example, for analyzing a particular condition. We have the eye tracker. There are a lot of works on eye tracker, looking at, for example, the pupil of the students, and when, for example, they are reading, which part of the text they will be concentrated. So this one you could do it, for example, by using the eye tracker. The mouse clicks, reading or going through a text with the mouse. So what is happening in terms of the clicks that you would have, or let's just counting the number of clicks, and then the seat pressure. Now, over here, we cannot say, well, EEG is the cheapest, not necessarily, but we see later on why we need to choose the EEG for our applications. Okay, the 1010 and 1020 are just conventional places in the brain for placing the caps. So, for example, if you look at over here, you will have different positions. So, in each position, you are capturing the electricity. Now, the convention is just fixed to say the 1010 would be a different set of places. For example, over here, you have the F7, F2, CZ, and so on. And for 1020, you have more positions that are considered depending on the number of channels that you are dealing with. Well, the success rate of EEG, well, it depends on the applications. We'll see it later on. Actually, sometimes it shows very good results. The challenge based, depending on the application, would be the robustness. That means how to make sure that we could use it in different, we can reproduce the same experiment or just go in real time and implement it, and how to make sure that it works. These are some challenges, but again, it depends on the application. Okay, so I was mentioning that there are different ways of capturing the physiological signals, but then depend on the application, some would be better than others. Okay, so here for us, we have chosen the EEG. We'll see later on why. Now, when we go for EEG, okay, I'm not sure it is there. Maybe I need to mention it over here. So why we go for EEG? Because first, we want something that could be implemented in a classroom. I will go back to this one later on. There are a lot of works that have been done in the lab condition. A lab condition, you are in a room well conditioned, if I could say, and then you just look at a small group of students. You get your experiment and get your conclusion. But for us, we were more interested in something that could be done in real life. That means I have a real classroom. I have, let's say, 20 students in a classroom. Can I use some technology to find out in terms of learning? So when we started the work, actually, we were combining EEG and eye tracker. But then when we thought about classroom, the eye tracker, first, the price is slightly high. And the other thing is that you may have a lot of interruptions that could affect the signal that you can get from the eye tracker. So it was a bit challenging to combine both, although it would have been better. But at the end, we just stick to EEG. Now, for EEG, for detection of interest, there are actually two main areas that has been where it has been implemented. The first one is advertisement, where actually we could understand, because when you do advertisement, you want to make sure that people looking at the advertisement, they will be interested to buy the product you're advertising for. So it's good to know where, for example, in some, if you notice, for example, in some supermarkets, they need to place the items in particular positions. This is just to make sure that the customer will be attracted, the customer can see it, and it should be in a way that they will go for buying it. Okay? So different ways of looking at the advertisement, but this is one of them, is just to, for example, use EEG to find out what will be the parts or what will be the ways of getting the interest of the potential customers. So this is just an example, detection of the level of interest or liking of an advertisement or TV shows using EEG. So there are a lot of works actually over here. That's for advertisement. The second application area is the education. This is where we want to do something. So detection of interest in learning content using EEG and mouse clicks. This is just one example that has been done before. But in general, people have been thinking of using EEG in education in terms of looking at the learning, or even in terms of the teaching as well, because it works together. Now, for example, when we talk about education, as I mentioned just now, we have the interest, which is the general interest, which is very stable, which is, for example, someone gets it from young age and just maintain it throughout his life. But we want to look at the detection in a particular case. You are teaching a particular topic. You have some students who basically they are not interested, but what you could do in a particular session, even if a short period, to bring the interest of the students on the topic. So that's why we make it a bit more specific. We're talking about the situational interest. Okay. Now, EEG, as I mentioned, one of the reasons actually was just that we want to focus on classroom. Again, this is just because one of the points that is happening in psychology, they're actually highlighted in many papers, that sometimes good results are there, but that's it. It's still there. It doesn't go to the implementation, to the real life implementation. So for us, we are thinking, well, if there are good results, and people have shown, for example, using psychology or any other field, shown that a particular way could be improving the learning or teaching, why we don't just go to the next stage, that means the real implementation in real life. Let's say, for example, in a classroom. But the ultimate goal actually of all this is a kind of dream, which is to have a feedback system. So feedback system, again, not in a particular condition, but in a classroom setting. So what does it mean? You are teaching a group of students, but you just imagine that every 5 or 10 minutes, you have the real feedback of the students in terms of their interest, or let's say in terms of understanding what you are teaching. Now, this idea was coming from a previous study where a researcher was using a handphone. Okay, you give a mobile to every student, and then you just ask them to feedback by using a local system in the classroom. Now, there were many challenges about that because first thing is that the students can just feedback whatever they want. Maybe they are not really bored, but just want to say that they are bored. So they can just send that they are bored. They want to finish the class now. Okay, this is one thing. The second thing is the distraction of the students. If you give them the handphone in the class, then not sure they will not only give the feedback, but they may do something else. Okay, but then the idea was really good. That means you are teaching, and anytime you know what is happening, and this is extremely important for us. I mean, for lecturers or anyone who is sharing knowledge, because if, for example, I'm having a class of 1 hour, if after 15 minutes the students are off, they are not following, they are really out of the scope, there's no point for me to continue. I would like to stop, maybe do something else for them to get back and then continue. So that's the idea, and I found it very good actually, the idea of having a feedback system. And the other thing is that, as I mentioned just now, if we use handphone, people can do whatever they want in terms of giving the feedback. But if you use EEG, it's not something they can control. It's something beyond their control. If you are able to find the features of interest, for example, so they cannot try to imitate or try to show that they are not interested, because that is embedded in the EEG signal that we want to detect. Some other motivations why we go for this detection of interest. Now, just some reference over here. In Malaysia, low academic performance among engineering students was associated with lack of interest caused by anxiety, perception of difficulty, boredom, and impracticability. So this is a few papers, few recent works looking at the low performance, and at the end, you will see that interest has a big role out of it, based on these research papers. So which means it's something that could have a big impact on learning. So if you are able to do something in terms of the interest, at least for the situational interest, then we may be able to help some students to improve their results. And another example is mathematics problem solving was found difficult due to the lack of interest. So they find it challenging because we are not able to get the interest, to bring the interest to them. So that means, naturally, let's say they are not interested, but on top of that, we want to, at least on a short time, to bring the interest to them. So if I'm not able to do that, then they might just lose and in terms of not able to do or to learn properly. And this is just another motivation. Interest energized learning, guides academic and career trajectories, and is essential to academic success. So this is a big claim because it's not only about, I mean, it's the whole process. Okay, when the interest is there, you are able to learn, and then you can continue with that even for the life after your studies. But this is exactly what you are looking into, and why it gives us somehow motivation to work on this area. Now, why we concentrate on situational interest? Our hypothesis is that we should be able to find brain patterns of situational interest. Here, brain patterns, I mean, if you are taking the EEG signals, there should be some features that could be able to differentiate someone who is having interest and someone who is not having interest. Because that is the first point, how to find the way of getting the patterns. And once we know that, then we have to work on it. That means we could even, for example, work on the material, how to develop the material. So I develop a teaching material. I want to check if it will bring the situational interest to the students. Okay. So if we are sure that the pattern is really representing the situational interest, then it will be very good in terms of testing, for example, a learning material. So this is the hypothesis. Now, if you look in the left side, this is what is happening in the lab when you are using wires, a cap with wires. So you have all these channels. It's probably 128 channels. You may have less, but as long as you have this kind of settings, then you have to forget about classroom setting. Because if you want to bring, and this one are people who are assisting to put the caps, and these caps sometimes is not dry caps. That means you need to put some gel to increase the connection. So that's why it needs some time to set it. But it's useful for some particular studies where you need many channels, and it has to be with wires to get better signals, if I could say. Now, definitely, if you think about this, we cannot go for classroom. Now, the idea is to look at this kind of devices where actually we are dealing with maybe one channel or just two channels, just at the front of the head, for example. And there are already a few existing. So that's why we thought it's something which is doable. And this is at this stage, probably it will be developed in a better way in the long run. So you can get something very simple that is not disturbing during the classroom, during the class, and where still you can get the signals. And definitely all these devices are wireless. Okay, so on the principle, it is something which is doable. Okay, this one I think I mentioned just now. There are a lot of works, a lot of papers published, either in terms of psychology or even in electrical engineering, where people look at very particular conditions. You are in a very specific condition in a lab. You have one or two students, and then you just want to study some particular events, for example, what is happening in the brain. Then it can be done, but our interest was actually how to go from the lab to the real life implementation. So then we need to extend and look at the ways of implementing. So it should be something very easy to implement, and it should be something robust in the sense that even if you are in a classroom, you may have a lot of noise and whatever is there, at the end we still want to get the main signals. Okay, and that could be useful, as I mentioned just now, in terms of improving the learning or teaching in classroom. So we will see later on that it's not only in one way. The students could improve their way of learning. The teachers could improve their way of teaching. And as well, the material that you develop for teaching, it could be tested if you have the right patterns, and to see if it could be improved. And so it's all good in all ways. Can we use SVM and KNN for processing EEG data? Yes, yes. I will show later on in the slides. We have used it for classification. Okay, so I was mentioning this is the dream. At the end is to get a feedback system. So this is just better feedback for better teaching. And this is what I was mentioning previously, a system where people use, for example, handphones, and they can communicate. They can you can do polls, you can do quizzes, but over here I'm getting it. I'm confused. So they have different options, and they can choose and just can give the feedback to the teacher or the lecturer. But definitely, as I mentioned, this is a risk because in terms of getting the focus of the students, they might be doing something else. And the second point is that it is something they can control. They can write something and actually they are feeling something else. Okay, so this was one of the motivations why we thought about using a device or devices to be able to look at the ways of getting a feedback. And that means if this one works, as I mentioned just now, you are in the classroom. You have, let's say, in your on your computer, the points representing the students. So it could be in terms of message, or it could be just in terms of a signal. For example, someone who is not interested at a particular time, you just put a color. For example, it is red, and if for the others, let's say it's green. That means over the time you can see how many people are getting the situational interest at a given time, at a given interval. That would be excellent, because then you can decide, well, if you see people are not following or they are not having any interest, probably you have to look at the way you are teaching at that particular time. You need to motivate or need to change something, do a small break or do an exercise. So that could be really something useful for improving the teaching and learning. Okay, now let's go to what we have done actually in our lab for this topic. So we're dealing with Inobio EEG devices. Maybe some of you are familiar with this. It has 8 channels, 8 EEG channels. So that means if you look at the cap, you just have 8 positions in the brain where you can collect the signals. And in a classroom setting, of course, each device should be connected to a laptop. Okay, so we don't have one computer to centralize. At the moment of the experience, yes, we are getting the signal sent to a particular computer, and then we did the processing offline. That means after the class. So MATLAB was used. We have the graphical user interface of EEG Lab. This is well known for those who are in this area, because as I mentioned at the beginning, when you get a signal, you may have a lot of noise, and there are classical ways of removing those noise. So for example, if you have the eye blink, you have different kind of artifact. So EEG Lab is well known. It has different tools, and you can do the pre-processing somehow easily. But at the end of the day, when you have your signals, you have done your processing, the statistical significance is extremely important. And people in psychology, I think they're very particular with this. So whatever you want to prove, you have the data, you have to do statistical analysis to show that there is, it is significant or not significant. So SPSS was used because it was easy if you are dealing with some, let's say here we have different students, you have different channels, you have different brain parts, and you have different inputs. So all these parameters, or these are level of variation that you have to consider when you do statistical analysis. And SPSS is quite good for it. Okay, so we had about 40 students from our university, all undergraduate students. Definitely we have to go for all this ethical committee approval. It has to be approved by the committee at the university level. We're dealing with mathematics content. So we make it like very short class of 20 minutes. Before we have what we call here the pretest. So we have the personal interest survey. So this personal interest is just a way to see if the students, for example, they already have the interest, which is the most stable in terms of, for example, mathematics, because that will have an effect. If I take 2 students, someone is highly motivated for learning mathematics, and someone who is not motivated for learning mathematics, these 2 will not be the same. So in our study, we wanted to just get people who are not really highly interested in mathematics, because then we want to see how the situational interest could improve, how to develop it, how to show, how to get ways of bringing it in, the situational interest, and then how to improve the learning of the students. Okay? So this is one of the things that we use. And then the academic tests to check the prior knowledge. Before we teach them a topic, we want to see if they already have some ideas about the topic. Okay, so for example, this one, if you take year one student, we teach them we ask them what they were feeling during the presentation. Okay, we will see later on the details at different times. The individual interest in different subjects is generally different, so we cannot correlate the interest level with the teaching. About mathematics, we talk about a particular topic. We'll see later on. For example, we talk about the Laplace transform. So they haven't learned Laplace transform before, but we just check if they have any interest, any particular interest that they, for example, develop. Some people, they are just interested in the group, because then later on it will impact in terms of how much is the situational interest that we develop. Okay, so then, as I mentioned here, we look at the situational interest. This is the post test, and then we have the recall test, where they have to answer a set of questions on the topic that they have learned. Okay, so that will show the difference between before the class, they have done the academic test on the particular knowledge to see if they have some ideas about the topic. And then we check after doing the process, are they able to answer the question? Did they get something out of it? Okay, so this is just the protocol. They have to wear the EEG all at the same time. We had set some cameras there to see everything is going fine. We have the pretest and the personal interest questionnaire. This is just to see if they have already some motivation of doing mathematics, for example. They have some particular interest. In general, in EEG, we need the baseline. So the baseline, sometimes we look at the eyes closed. That means we ask the student to sit down, just try to empty their brain. We just look at the base signal that is there. Because from student to students, it could be different. Sometimes people use as well the eyes open. Same condition, you just ask them to sit quietly in a place, let them relax, and then you just take the EEG signals. It could be just for 1 or 2 minutes. And so this is eyes closed and this is eyes open. Next, we go for the learning content. That means there's a presentation given by a lecturer. And the signals are taken from all the participants during the whole presentation. So we have something like 20 minutes plus minus of EEG signals for each participant. Okay. After the class, we do again the same. We go back and look at the eyes open, for example, baseline, what is happening for these students. Then, as mentioned, we have the post test, and then we have the situational interest questionnaire, where they need to answer a few questions regarding the session that they just finished. For example, I will show later on, we have different subtopics. So they could answer based on the subtopic. For example, okay, at this particular subtopic, I was not really interested. And this particular topic, I was really interested. So this is something that we use for the next step. Okay, this is the overall questionnaire about the presentation. Okay, not going into details, but just the overall presentation. What are the different what is the output from the students or from the participants? And the last part is just to do the processing and then the analysis. Okay, this is how it looks like, the setup. The EEG cap, this is that one you see at the head of the students. Okay, so we have the laptops placed somewhere either in the side or behind the students. and this is the projector. This is, for example, we just show them like this is for eyes open. Okay, we just ask them to relax, and we take the EEG. You could see there's a camera here. So we capture all these things and then see how we could improve. I mean, what we could develop in terms of learning. Now, how do we get the ground truth? What we have used over here is based on the situational interest questionnaire, which is the just a questionnaire where we can put some marks at the end of it. So we get a score. So we just split it by using the median. For example, the high score between 77 and 100, this is considered as high situational interest for a particular student. Okay. Low situational interest will be less than 69, and then moderate will be in between. Now, what happened is that we were looking at high and low. So we did not include the moderate situational interest. We could do it, but then the challenge is that there may be some overlaps between the groups. So here we just wanted to concentrate on the big difference between high situational interest and low situational interest. Maybe in future work, there should be a way to think about incorporating the moderate situational interest, because definitely there will be some students in that case. Yeah, actually, yeah, the EEG actually is known to be harmless because it is very low low voltage, so it doesn't really harm. The most you could get, or let's say the worst could happen, is just feeling discomfort by wearing the cap for a long time. But here, if you have noticed, we mentioned about 20 minutes, maximum half an hour. So in general, there is no issue. And in our protocol, definitely the students, at any time they feel discomfort or they want to just stop the experiment, they can just call the attendees just to stop the experiment. There was no issue. And in our protocol, we have as well connection with a clinic in the lab, I mean, in the university, where they could just, if anything happens, so we have to get. But in general, there was no issue. How to choose 76 and 69 as the remarkable score? Yeah, I was mentioning that we use the median. So we look at the median, and then we look at what should be the right threshold to remove to get the higher score and the lower score. Okay, so just based on the median. We prefer the median to the mean because when you use the mean, if there's any outlier, it will just change the whole thing. So median was better in terms of calculating the intervals. Okay, now another thing that we have done is, for example, we talk about Laplace transform. Okay? This is something that they haven't seen before. How high and low score in the same set of students will affect the educator. I'm not sure I'm getting it. The same set of students will affect the educator. Well, the educator in terms of, because let's say we are trying to find a way to detect people who are highly interested. Now, yes, there's a kind of relativity, because if you take some groups, maybe looking at the median, it might be a bit higher. But the principle in terms of looking, once you decide who is interested and who is not interested, you just want to see whatever you implement in terms of, for example, teaching method, what will be the reaction of these two groups. You want to see the difference. Or you want to see in terms of EEG patterns, what will be the difference between the high and the low. I hope that answered the question. Okay, now we look at the points. So what we have done is we just discuss with a specialist who is very a specialist of content design. Okay, so you have your slides, and there are ways of making it interesting. So we consult the specialist, and at the same time, we show those slides to a group of students that were not involved in the experiment. This is before the experiment. So we show them the slides that are made for the experiment, and we ask them to rate the slides. Okay? So at the end, we had the opinion that it was like interesting slides. And we divided in different subtopics, sub points. You could see over here. At the beginning, we have introduction. Then we have learning objectives. Then we look at real life problems, because we knew from previous literature that some students, they are not interested in a particular topic. For example, they're not interested in Laplace transform. But when you tell them about the applications, something that they could live, if I could say, as engineering students, that could bring some interest. Okay, so we include real life problems, definition of Laplace, definitely they have to go through it, the notations. Another point that was highlighted is about the history of Laplace transform. Even the students who are not particularly interested in Laplace transform, when you start talking about the history, what was the different stages until we got this transform, then some, they got attracted. I mean, the interest is developed. Okay. Then we have the example. We have then a few, for example, unit step function, what is the definition? We add a challenge question. This is again coming from the literature review, especially from the psychology, that when you bring challenge question, some people will be attracted, will be interested. Okay? So this is a way at a particular time to bring the interest. Now we have then the table of Laplace transform. We have some examples, and we talk about the inverse and so on. Okay? So some of these points are particularly good in terms of bringing interest to the students. So that was some of the reasons why we add them. Now, based on the previous splitting of the groups in terms of high interested and low interested, this is what we could get from these points. Just an idea, for example, if you look at the low interested, you talk about the introduction, it's not a big deal for them. You look at real life problem, some of them, nothing. You look at D, definition of Laplace, not much in both. You look at E, notation of Laplace transform. Some people are interested in it. Over here, the low interested, still nothing. Some, they got a bit higher when you talk about M is the table of inverse Laplace transform. So sometimes it's not really something that we could explain why at the particular time or this particular point, this particular subtopic, they're getting the interest. But overall, we can see that we have higher values for high interested students, just roughly to have an idea about the difference between the two groups. Okay, why Laplace was chosen? Actually, nothing special. It's just because it's a topic that these particular students did not learn. That's why it was chosen. But it could have been anything else. As long as they haven't seen it, then we could just see how it will impact them. Okay, then we start talking about finding some features. We need to extract some features. So we have the signals. Definitely, if I take 20 minutes of signal, it's too long. Okay, and just remember that we are talking about having something in real classroom, and we need to find a real feedback. So the processing of the EEG at the end stage should not be something very complicated, should not be something very long. So we need to extract some features, and the extraction should be fast, so that the classification later on would be fast as well. Okay, so we talk about the approximate entropy. Why it was chosen? Because there were previous papers that show that it has a potential in terms of EEG features. Okay, so just a few words about the approximate entropy. So quantify the repeatability and the unpredictability. So moderate length of EEG data and then underlying changes. So if there are some changes, it should be captured by using the approximate entropy. Okay, so we have the definition over here. I will not spend too much time on this, but once you have the signal, there are specific ways of processing it to get this approximate entropy. We have the equation just to highlight the origin. But in practice, we just use MATLAB and get the coefficients corresponding to it. Okay, there's a spike in the graph. We go back for a while. Yeah, what happened at M? M is the table of inverse Laplace transform. Yeah. Yeah, there's a spike, yes. Why it is happening at this particular time? Not really sure, because this is just the definition of just showing the table of inverse Laplace transform. Not really sure. Can we conclude that compact information incites interest in the students? That could be a possibility. Yeah, that could be a possibility. That means the fact that everything is summarized in the table, then probably they could find it maybe easy to get the information. That could be. Yeah. Okay. Now we have the baseline over here using the approximate entropy. We have the baseline. We have the lecture. We just select short period. So moderate length. Actually, this is even relatively short, 30 seconds. We get the features, and then we look at the percentage of change, the difference between what happened during the lecture and what happened during the baseline. Okay? Baseline, for example, being the eyes open that was taken right before the lecture. So we get some coefficients, and we could use them to differentiate between the high interested students and the low interested students. Okay, just to have an idea about, because before going, once we get some features, before going for classification, we just want to have an idea how, if you plot or just look at the t-test, we just do a t-test between the two groups and see if there will be a significant difference or not. Okay? So here we have the plot for a few points. We are getting here 0.05, which is not too bad. This is using channel O1. Okay, so this is just in the occipital. Occipital means towards the back, where actually the visual is situated. Okay, which we could understand because when you are learning, the visual will be activated. And for channel O2, it's about the same, slightly less than 0.05. So if we set the 0.05 or 95% of confidence, so we could say, yeah, it could be a potential candidate to be used as a feature for going to the next stage, which is doing the classification. That means, can we differentiate the two groups by using this approximate entropy? Okay, this is just used in general just for representation. This is the brain topographic maps. So we're looking at high interested over here, a few students, and low interested over here. So, for example, what you could see over here is in terms of for low interest, that you look at the back here, this is where you have the occipital I was mentioning over here. Most of these are blue. Okay, that means the level is a bit low, the level of activation. The more activated, we go to the red. Over here, yes, this one is blue, but you see a few among the highly interested where you have red. So you have on the occipital, you could say that there's a difference between the low interested and the high interested. Okay? Over here, most of them, they have red, that means highly activated. But in the low interested, you will have more in the blue, that means not that much activated. I think this is interesting. It will be useful in all conditions. I mean, I would say in wherever you are teaching, you have a group of students, you want to improve the way of teaching or the way of learning, it could be interesting to consider. We'll see later on in practice what could be done. But definitely there are some challenges. We'll look at it later on. Okay, then we look at some other features, the singular vector decomposition. So again, if you just to recall the process, we have the signals. We want something that will be easily processed, for example, for doing machine learning or doing classification later on. But since we are talking about real time, or at least near to real time, we want features that could be obtained easily and that could be just processed in a very short time. Okay, so the first one was approximate entropy. Then the second was the singular vector decomposition. So again, we look at over here, for example, the EEG. We have is like a matrix. N is the EEG data, and P is the number of channels. For example, for us, the number of channels was 8. If you remember, I was mentioning the Inobio. The device has 8 channels. Okay, so we have a matrix. You do the decomposition. You will get some singular values, and then you arrange from the largest to the smallest. So similarly, we are looking at how much change is there from the baseline compared to the lecture. And then we use this as a feature. We want to see if this would be useful for differentiating between the highly interested and the low interested students. How will this study be applicable in the current scenario when? Yeah, that is a very good and challenging question, but we will discuss about it towards the end. Okay, so the question is that in terms of, now we are talking about online teaching. Yeah, we'll see towards the end, but definitely this was done before COVID-19. Okay, so this is just another tool of getting a set of features. So we just use SVD. So this is just to explain the process. But at the end, we just have a vector representing representing each person. So then we want to classify later on how to differentiate. Yeah, the question I think, Dr. Amrita, I think is the same as previously. So how relevant is this tool in online education? So we'll discuss it towards the end. But again, definitely, this was initially done in the context of face-to-face teaching. But we see what could be done in terms of online, because that's now the mood. Okay, another feature that we look into is the EEG bands. So the EEG usually are decomposed based on the different frequency bands that are classically used in all applications. And they have the name from alpha, beta, theta, delta, and gamma. Okay, so this is just decomposition based on the frequency. So you just put different frequency. And we want to see what these bands could impact in terms of differentiating the two groups. Those who are high learners and highly interested and low interested students. So again, we just do a t-test initially just to see what are the potential candidates. Okay, so looking at the 8 channels that we have, we do a t-test at different bands and look at the values that have that are less than 0.05. That could be significant. Okay, so we see over here for delta band, we have 2 of them. Theta, we have 1. The rest is not really significant. So once we know that it's not significant, we don't need to go ahead with these features, because definitely they will not be able to give a good result in terms of differentiating the two groups. Okay, so then we concentrate on the delta band, because this is where we have 2 values that are less than 0.05. And we can see, for example, in frontal, we have a big difference between low interested and high interested. And similarly, in occipital, in the back, we have differences between high interested and low interested. So then we say this could be a good feature to use for the next stage. How effective EEG can be applied? Well, we have seen, for example, for us, we have done it for a channel of a device with 8 channels. So we are saying that if you want to implement in a classroom, we need something lighter. It could be just, for example, 1 channel. if we are able to show that among all these positions, e.g., locations, there is one that is good enough to make the difference between the two groups, then definitely this could be at least tried in a real classroom. Okay? Of course, we need to get constant, and everyone needs to agree on using them. But if we are showing that it is good enough to differentiate two groups, then it could be a good base for getting a feedback. Okay, now, if you remember, for machine learning, once you have any system, you have to check about the performance. So I will not spend too much time on this. Let's say this is true positive, false positive, false negative, true negative. In general, people will report the accuracy. That means if, for example, we get a system to differentiate between high interested and low interested, and then we use the score that they have, how good is our system, we can just report it in terms of accuracy. Or we could include as well some of these values, the F-score, specificity, and sensitivity. This is just to remind that whatever you develop at the end, we need to check how good it is. Okay, now we have checked three features: the approximate entropy, the SVD, and then we have the delta power just now. When we did the classification, the results are as you can see over here. They are not that high. The approximate entropy is giving 80% for SVM. Just now, I think someone was asking about the classification. So we use over here the supervector machine and the KNN. Yes, that's right. For online classroom, facial, head gesture, eye tracker, and mouse clicks can be used for this study. Yes, I think this could be used. It could be used, but definitely there are a few challenges. Because again, what you want to do is something that is somehow easily implementable. You can implement it without too many challenges. And if you think about, for example, a big classroom, so again, we need to find about among all these tools, what are the simplest in terms of acquiring the data, processing it, and giving a feedback to the lecturer. That will be the challenge. But definitely this could be used. Okay, EMD is just another way of getting some features. So for those who are in signal processing, probably they have heard about it because it's somehow well known. So the process is described over here. I will not go into the details, but at the end, it's just kind of decomposition. So I have a signal x of t. I follow this process. So here we have the upper envelope and then the lower envelope. We take the mean, we subtract it from the initial signal, and then we get something that we call the H1. So from this H1, we just have to repeat the process. At the end, we have the signal, and then you have some residuals. Okay, there are some conditions that the residual need to satisfy, but the most important is that when you apply this process, each signal would be decomposed, and you have this way of writing it. That means it's a combination of what is called the IMFs, intersect mode functions, and then you have the residual. Okay, that will be a qualitative study. You can quantify such gesture remotely. Well, if you have, for example, an eye tracker, there are different ways of getting some features out of the eye tracker. So that could be something quantitative, but then you have to see what would be the best that could differentiate, for example, some students who are interested and some who are not interested. Okay, so looking at this feature, then we can do the same. So I just highlight the features first, and then we see what did we get in terms of result. The next one is the wavelet decomposition. So this is just a representation of it, but you know that for the decomposition for wavelet, you give a signal input. The output could be just a set of coefficients that are representing that particular signal. This is how it looks like when you do the decomposition using wavelets, depending on the level of decomposition that you are considering. But again, at the end, you have a set of coefficients. So you want to see these coefficients from wavelet, can they be useful in terms of differentiating the two groups? So when we implement the last two, which is the wavelets, and then we have the EMD. So we got 71%. That was the highest we got, and then sensitivity 83, specificity 44. Okay? So we thought this is not good enough to be implemented, for example, in the classroom, because that means 29% you are, for example, placing someone who is highly interested in the group of low interested. So it may not be effective. So we needed to improve what we have over here. Then we talk about extraction of region of interest. Okay, I will explain later on. Because actually we have a signal 20 minutes, but this signal 20 minutes is not all good. Some parts may not be that good in terms of differentiating. So whatever we develop in terms of features, we don't want to apply it on the whole signal, but we want to extract some parts. So this is what we call the region of interest. We'll show later on. The next improvement could be in terms of the wavelet parameters. As you may know, for wavelet, you have, I would say, maybe hundreds of functions. So how to choose the right function for this particular application? So we look, for example, at the vanishing moment. So if you just take the model wavelet, it will have a particular shape. So which among all the possible, at least a group of possible wavelets, which one would be the suitable for this particular application? Then we look at the decomposition level. So if I do a decomposition of signals, I could go level 1, level 2. That means how much fine details I want to find, I want to get from the signal. Then I could decide if I stop at level 2 or level 3, level 4, what will be the effect. Okay, so we just look at this this particular thing. So for region of interest, it was based on the different points that we have. But then even in the signal itself, we try to look at the segmentation. So if I, for example, have a portion of about 1 minute, we could look at the video, because we have the video for the session. We could look at the session, I mean the sections where we don't see it will be helpful, it will be useful in terms of differentiating. For example, at the particular time, there's some students that not following. Okay, so those parts could just be removed, because we want to see when the whole group is somehow active, and then just based on the EEG, how to differentiate them. So region of interest, the total length at the end was just 2 minutes. So what we have done is just we look at doing a classification using the signal without the region of interest, and doing the signal with the region of interest. Okay, and see how it will impact the classification. Okay, so for example, just an example. Instead of taking the 20 minutes, 22 minutes for some cases, we just look at, for example, 2 minutes and 34 seconds, depending on what are the particular parts that we want to focus based on the topic or the particular point of the lecture. So when we did that, there were some improvements. Look, for example, at the accuracy, instead of having 71, it goes up to 81, which could somehow could be understood in the sense that if I look at the whole signal, some portions do not have any effect in terms of the teaching, but if I use them for my classification, the classification may go down. So if I remove them, I just focus on the region of interest, so it is expected that the accuracy would go up. Okay, and then the next one was about the wavelet parameters. So this is just a few of them in terms of relative error. So you see W is 2, W is 4 for those who are somehow used. But these are just different types of wavelets. And the particularity will be in the mother wavelet that is used. So some will be more adapted to the kind of signal that we have. So then we do an experiment to see which one is giving less error, and then we just select it. Okay, so this is the relative error. I think at the end we use the DB4. Similarly, for wavelet decomposition, we have different coefficients. So we will look at various levels, as I mentioned just now. We could do the decomposition at level 1 or level 2. We get some coefficients. We check how good they are in terms of differentiating the two groups. Or we go to the next level. So we compare a few and see how it improves the results. Okay. At the end, we look as well at the segmentation. So if I have a signal to a certain length, I want to cut some portions. So how to choose these portions? The portion should be valid for all participants, so that it is something we are not losing any person or any data. Okay. So if I have a small section of, for example, 14 seconds, which is good for one participant, I need to make sure for all the participants they are active at that particular time, and we have good signals, and we can use it for doing the processing. So in our data, we're able to find this kind of length. So that's why the numbers are a bit arbitrary, because it depends on having a particular section where all students, I mean, we could use the data of all students that were in the experiment. So again, we look at what is the performance based on the length of the segment. So we could see, for example, for 14 seconds, we are getting much higher compared to the others. So at the end, to go to the next stage, we just use the 14 second length for the segmentation. How parameters are chosen? Okay, I was mentioning just now, actually, the one parameter is just choosing the model wavelet itself. So for example, in our data, we just select a small portion of the data, and we just run with different model wavelets and see, for example, here we have the relative error, but we could look as well at the accuracy. So we just choose based on this. Okay? So this one is a kind of validation for those who are used to neural networks. So I have a set. I will use a small portion of it just to check how to tune the parameters. So that's the idea over here. Okay, so when I mentioned, so as well, same thing over here. I have different possibilities in terms of length of the segment. So we just choose the best one to go to the next stage. Okay, so we have EMD separately, we have wavelet separately. Then we thought, why not we combine these two? Most of them are ways of extracting some coefficients after doing a decomposition of the signal. Okay, so this is something new in the way of doing it, because we started with doing the EMD decomposition. Okay? These are the coefficients, I mean, the different functions that you get. If you remember, you have a sum of CIs, and then you have a residue, which is R. Now, initially, what we did was just using this decomposition to do the classification. And then we do same thing, but instead of EMD, we just use wavelet. Now we are applying wavelet right after the EMD. Because once we do the EMD, we have some functions. We could just apply the wavelet decomposition on these functions. So we are getting the coefficients representing these EMFs, and they are all representing the function, the initial signal. Okay, so at the end, we can concatenate all these coefficients and set it as a vector, and this is the vector that represents the signal. So that is the one we want to use for the next stage, for seeing if this is good enough to differentiate, for example, the two groups. Okay, this is, for example, just looking at the percentage of energy corresponding to the approximation. Okay, so we look at this, and when you do wavelet, you have a large number of coefficients depending on the length of your signal. So we try to find the features. So again, we are just looking at, for example, we start with a certain number, the number of coefficients. We do the accuracy, and then we increase the number of coefficients, look at the accuracy. So we can run it for a while in a small data set to see where we can get the highest accuracy. Okay? So for example, over here, it happened at 220 coefficients, features or coefficients. So when we combine these two features, the EMD and the wavelet, and we consider as well the feature selection, that means how many features you are taking, and this is what we obtained. The best result was obtained for EMD wavelet, energy with feature selection. So this is 90.5%. That was the highest obtained for this data set. Yeah, the wavelet, one of the most known is the WCHs. That is the abbreviation of dB. So even among the WCHs, you have different. That's why you see the names dB1, over here dB2, dB4, dB6, until dB10. And you have many more. Okay, so we just select based on the result that we have over here. Okay, so this is what we obtain. The highest percentage, definitely when you want to see what people have done, we had to do some comparisons. And I didn't put all the details over here, but some of the previous works, probably I did mention it previously, they did not focus on the classroom setting. So some of them were just done in a small scale. For us, we consider that because we consider up to 40, that is quite reasonable in a classroom. Although, for example, in some conditions, you may have a lecture hall where you have more than that. But at least for the proof of concept, we consider that 40 could be a good number. And we try to do it in a real class setting where the students are learning in a particular topic and we are taking the EEG at the same time. So by comparison, we are still getting good results compared to the previous works that have used different methods. Okay, so that's for EEG for detection of interest. This is what we have done. And we could think about what should be next. I just did not include it, but we have published a few papers for this work. But it's all right. So we have the feature work. What we started doing over here is how to include a clustering. Okay, the clustering of students based on interest. So right now, what we have done is we look at the features, we get the good features, some good features, and then we do a classification. Of course, when we do classification, we cannot use the whole data set. So we use one portion of the data set for finding groups. Data set. So this is how we get these percentages. When the device WCHs wavelets are applied to the already decomposed. Yeah, for the combination of EMD and wavelet, yes. Because when you apply the EMD, you are still writing your initial signal as a combination of signals. But then when you apply the wavelet, you apply it to each of these signals. Okay, so the first decomposition is not wavelet, it's just the EMD. Probably I could just go back shortly.
Yes, sir. Thank you.
Okay, that's fine. Yeah, the EMD actually just writes the signal as a sum of signals. These are the EMFs. So once we get these signals, we apply the wavelet on these signals. So we get set of coefficients for each of the signals that we can just combine, make it a vector, and use it as for classification. Okay, we're somewhere here. Yeah. Okay. So the feature work I was mentioning that what we have considered after this, the previous work was about clustering the students. So which means we don't want to go for classification, but we want to find a way to cluster the students based on the features. So from the previous work, we have a few possible features that could give good result. Okay, for example, the last one is combination of EMD and wavelet. So we get some good coefficients, and based on the classification, they could easily differentiate between high interested and low interested students. Now, what we want to do for the next is we just use these features, but we don't do classification. We just want to have two clusters, two groups automatically. That means, for example, you are teaching and you have a way to have on your computer the two groups. One will be highly interested and the other one will be low interested students. And this one you can get it over the time. That means it could be changing, as we have seen previously, depending on the subtopics. Some students will be interested and some will not be interested. So you can have, for example, every 5 minutes, you have an update. How many students are interested and how many are not interested. Okay. The second point for future work is something called the brain-to-brain synchrony. Because now we are talking about learning in a classroom. So there is definitely an impact between the students. This is the first way of looking at brain-to-brain synchrony. That means what is happening if you take a group of students, is there anything happening, any correlations or any ways to look at the brain of all the students? So this is brain-to-brain between students. Another thing which is still called brain-to-brain, but this time we could look at the teacher himself. What is the connection between the brain of the teacher and the brain of the students? So can we get some information out of it? Because that would be extremely important. Because from the previous work, we talk about the way of differentiating high interested and low interested. But we know that this could be affected by the teacher himself. So why not connect everything, that means the students among themselves, at the same time, the connection between the lecturer or the teacher and the students? What will be the effect of, what could we see in terms of the connections between the brains? And the last one is the one some of you were highlighting just now, is about the online teaching or learning. All the things that we have done in terms of teaching and learning, how we could use it. So if you notice, for future work over here, I put the question mark at the last one because I don't have the answer. It's something that is challenging for everyone. Of course, some people are working in this area in terms of developing tools for online teaching. But at the end, all of us, we have to think about what are the best ways to make sure that the students will learn. Now, if I look at the first one, which is about the clustering, this is a work that we are continuing, actually we are still doing. Let's say this is the preliminary results. We have a small group, we use some features, and then we want to just use a clustering method. It could be, for example, just any simple clustering method. So we just consider two groups. Okay, so we have the high interested and low interested. But when we cluster, we don't know which one, who is who, if I could say. This, for example, when we use the mean alpha power. So alpha is one of the bands, depending on the frequency. And when we do the automatic clustering, this was just using by k-means. Okay, k-means is just a method for clustering. For example, if you say that k equals to 2, then you get two groups. And this one finds automatically. There's no database, or there's no ground truth. We don't use the ground truth, the one we obtain from the score by splitting in terms of the median. We don't use that. So we are just saying that if I use a feature, any feature, I should be able to just automatically do a clustering. Now, if this one works, that means we could at any time have just this plot every 5 minutes, and we could actually even have the names of the students appearing over here. So you know which student is, for example, interested at a particular time, and which student is losing the interest. So every 5 minutes you get, for example, an update. I'm saying 5 minutes, just an example. It could be something longer, it could be something shorter. So here is another group. When we have two clusters, cluster 1, cluster 2. So most of the students are over here. Probably these are the interested students. And there's one guy far away. So probably this is the non-interested student. Okay, so over here we did not specify the students, because just like want to see how it works. But definitely this could be implemented, and this could be the way of going for the real classroom feedback. Because now, as I mentioned just now, I'm not even using the classification. I don't use, for example, the score of the students. I just have a group of students based on the features that have been proven somehow in the previous study. I just want to use it to classify, I mean, to have two groups, just to have a cluster of students. Okay, that's for clustering. Yeah, this is ongoing work. Hopefully we can get something good out of it. The second point I was mentioning for feature work is the brain-to-brain. So this is brain-to-brain synchrony tracks real-world dynamic group interactions in the classroom. Actually, in the classroom, when you are teaching, sometimes we set some subgroups because of particular work. But naturally, the students themselves, they might be just putting themselves in subgroups, something that we could see or we could not see. But in terms of socializing, some people, for example, if you ask them to do a work, they will tend to go to some students. So they will naturally form kind of groups. So this work was published, I think, 2019 or 17, I think 19. So they were looking at the brain-to-brain among the students. So can we get something out of it? Right? A kind of pattern or kind of feature to look at how the students are learning, how they are understanding, for example. So this is one of the output. This suggests from the results of this paper that brain-to-brain synchrony is a possible neural marker. So we are looking at a marker. Previously, for example, we use the features from the EEG, looking at the coefficient taken from the decomposition as a pattern. That means it could be good enough to differentiate. So here they are looking at the connection between the brains of students, and the output is that it is possible to be used as a neural marker for dynamic social interactions. That means if I have, for example, a subgroup of students, you have deep connections among the students. Probably this is a sign, for example, that they are learning. And I take another subgroup, maybe the connections will be different. So it could be a sign that they are not learning or they are not getting at that particular time. So this study validates a promising new method to investigate the neuroscience of group interactions in ecologically natural settings. So for teachers or lecturers, this is really interesting to know in general, because now you are looking at how the students are learning and what could be the way, for example, to detect that learning is happening or not, and probably some intervention. Intervention, that means what could we do to improve the interaction among the students, or let's say this brain-to-brain connection. How specifically we need to allocate the frequency bands to various stabilities wavelet transformations after SVM. Well, actually, the SVM would be at the end, because the SVM, you use it as a classifier. So for the frequency bands and the wavelets, this is for getting the features. There is no particular way of doing it. We have to choose based on the result of the SVM that will come later, SVM or any other classifier. That means, for example, for us, we try different WHs, and then we see in terms of classification which one gives the highest result, and then we use that for the next stage. So similarly, if I have different bands, which band will work, and which set of coefficient or which features I need to use. It could be explained in the sense, for example, when we look at the different, just now I was mentioning about occipital. The occipital is a region which is involved during learning because this is the visual cortex is situated. So we can expect that the occipital will have an impact. Okay, but then after that we need to do it. I mean, by using the experiment, using the data to show that it works. So similarly, you have different functions of different part of the brain. So depending on what you are targeting, then you have to choose accordingly. If you remember at the beginning, I showed the different parts of the brain that are involved when someone, for example, is interested in mathematics. That means in practice, we need to look at those details, I mean, those regions. This is where we can expect to find good features to differentiate high interested and low interested, for example. Yeah, I hope that answered the question. Okay, so that was brain to brain. Brain to brain, the previous study was mainly actually between students. And this one actually is not yet published. It's just for the time being in the bioarchive. And it's about the same group of authors. And these are somehow the top guys in this area. Now we're talking about brain-to-brain synchrony predicts long-term memory retention, which is exactly what we want. We want the students to be able to not only have the knowledge, but to be able to maintain it. Okay, so more accurately than individual brain measures. And over here in this paper, they look not only for the connection between the students, but at the same time, they look at the connection between the teacher and the students. So this is extremely interesting because of, in terms of retention, as I mentioned, this is normally what we want. We want the students to be able to remember what they learn. So this is what they have done in this paper. The main challenge, or maybe the main difference where a lot of work needs to be done, is that this is, again, in a very particular setting. Okay, and they have used a group of 4 students. So you have the lecturer having the EEG as well, and then you have the 4 students, so using the computer, and the presentation is happening over here. Now, it's very good, I mean, in terms of proof of concept. But for me, for example, I would be more interested in going forward. If I am having a class, I wouldn't say 100, but let's say you have 20, 40 students. Can we use this kind of techniques, knowing that, for example, we cannot imagine all of them having a very heavy EEG. This is maybe just for this experiment. But in the real life, you would like something very light. For example, just one channel, okay, one simple EEG that everyone will wear, including the lecturer. And then can we find the same results and show that it works? That means we can find the way to characterize the brain-to-brain synchrony between among the students, and then including the lecturer. And once we have this, can we use it, for example, for improving learning, and how it should be done in practice? Do with cognitive and lateral thinking. Lateral thinking, I'm not sure, but cognitive, yes, because the brain will be activated based on the topic that you are learning, or the conditions in which you are learning. Yes, lateral thinking, I'm not really sure in which sense. Okay, so for me, this is something to be done. That means using some biomarkers, or EEG biomarkers, could be used in terms of individually. So we look at the people individually. But more interestingly, since we are talking about classroom setting, we want to see the different reactions. I mean, the different interactions between the students and between the students and the lecturer, and use it as way of improving the learning and or teaching and learning together. Okay, now we're talking about online. So I was mentioning that personally, I don't have the solution. I just know that it's extremely challenging for implementing whatever we have developed over these years in terms of online application. Now, there are probably some other ways of doing it by looking at the, as someone was mentioning, for example, you have the eye tracker. But again, we want something very simple. So if there's a way of, for example, still getting the EEG, because this is at the end is all signals that you could send in a server or could be all connected and sent to the computer of the lecturer. So in that case, it could be done the same way, because once you get the signal, it's just to be sent in real life and then apply the same process. So in that sense, yes, it could be implemented. Now, practically how it works need to be is something to work on for improving. Probably, if this condition of online teaching is continuing, myself and my colleagues, we have to work on that direction. Now, I highlight here a few points that are somehow known, at least in psychology. They mentioned, for example, frequent assessment is a way to improve learning, at least to improve the focus. Now, for example, you are teaching online. I tried it even yesterday. I was having a class, so I was just calling the students randomly. Okay, so for example, for yesterday, my class is about 90 students. I called randomly 4 students, 5 students, 2 were there. So I got 40% of, which is relatively small. That means sometimes they are connected, or you feel they are connected, but they are not there. They're doing something else. Maybe they're gaming or doing something else. So I was thinking, yeah, if I just do frequent assessment, so it could be randomly, I just set a random set, a set of quizzes that will happen at any time. So that probably will force them to be there, because definitely they don't want to lose the marks. Another point which is much highlighted in this area is about the interactive sessions. Because sometimes you don't, for example, you have a class of 2 hours. If there's no interaction, it's very challenging for the lecturer. Just like you are talking to your computer for 2 hours. It's very, very, very challenging. So what are the ways to make sure that there will be interaction? That means you'll be engaging your students, and that could be the way of improving the learning. And the last one, actually, I already mentioned, is about the online teaching and learning. Based on our previous work, probably there are ways to implement it, but this is something that we have to work on and see how it could be done in practice. Okay, probably I will just conclude from here. The incorporation of brain-to-brain synchrony for me is highly interesting, and look ways of seeing how it could be done. Again, as I mentioned, from the paper, it shows the proof of concept, but then it's done for a very small group, which is like 4 students, and we would be interested to see how to bring this to the bigger classroom. The feedback system, it has some challenges, but I still believe that it's doable, especially when we look at the clustering that we are working on now. So it will be very simple once we have the right signal. So it's just kind of a display. You just need a display in front of the lecturer, and this could be even done in online teaching, where you can have the students who are interested in a particular color and with their names, for example, and that could be good to see how you could improve or change the way of teaching and so on. And even if you can't get the feedback system, at least a way of checking any material that we develop. So we develop these tools, so we can check it with some students when we develop a new material and see in terms of interest how many would be interested. Definitely, there will be some subjectivity of depending on the topic or depending on the batch you are looking at, but the ways of doing it. And the online adaptation is the one I mentioned just now. I still believe that there are ways of doing it, but to bring it to the way of having it implemented and to have the robustness. The robustness again is that you do it and you give the method to someone else, either in India, in Pakistan, or any other place. He the person implement it and obtain about the same results. This is probably the challenge that we could see over here. Just to finish, this work is done with a group of students. Dr. Arij just graduated this year, earlier this year, and we have some of the students still working in this area, which is about the science of learning. And since these students, some of them are in the engineering field, we are trying to see how to use these physiological signals to improve the learning and the teaching. I think that's what I have for today. Thank you so much. I'll be ready to answer questions if you have any more.
If any participants have any questions, they can unmute your mic and ask the question or write in the chat window. You can take 2-3 questions.
Dr. Ibrahim, can you show me your first screen, first slide,
Yeah, sure.
please?
Hello, Dr. Vishal Jain.
Yes, sir.
Hello. Sir, I have a question.
Yeah, sure.
Sir, my question is, sir has discussed basically the mathematical modeling uh, of the behavior or emotions of the learners,
Okay.
whether they are interested in learning or not.
Yeah.
Actually, my question is how a teacher or an instructor makes the learning more interesting or interactive for the students, so that we doesn't need these methods and the students, him or herself, feel that the teaching is an interesting or interactive talk.
Okay. So, for example, I was mentioning initially the experiment that was done by some other researchers by giving, for example, handphones to the students, so they can feedback directly to the lecturer how they feel. But again, this is something which is subjective. I mean, the students, they can feedback something different to what they really have in them. So what we are suggesting here is something which is independent of the students. We just want to be able to find the feelings or finding the stage of the students without them being able to modify anything. So that's the main idea.
Okay, thank you very much for your answers. And
Thank you very much.
and your work or research work regarding this study of the detection of student interest is excellent, sir.
Thank you so much.
I'm very happy to see it's a very rare topic on which you have done your research. Thank you.
Thank you so much. Thank you. Thank you for attending. Thank you so much.
Any other one would like to discuss or ask queries? You can write in a chat window or unmute your mic and ask.
Someone was asking, will you kindly elaborate EEG? Yeah.
Vishal, I think if there are no questions, we can conclude it. Huh?
Yes, sir. I'm just checking on the chat window, sir. If there
Yes.
are
In chat window, there were many questions in between the lecture that I could see. You go to mid of the chat window, not last, mid of the windows.
So there is a one question: why you choose EEG, not other sensors like ECG?
Oh, okay. Because for interest, it's more about the brain. That means we are looking at the features that are in the brain, because this is for learning. If you look ECG, it will be more about the the heart, for example, what are the signals that you can get from the heart? There may be some connections, but since we are talking about the learning, which is involving some parts of the brain, as I have shown in some of the slides, so EEG was more appropriate for getting those signals.
Thank you, sir.
Welcome.
I think there are no any pending query or questions, so we can wind up the sessions.
Yeah, Dr. Ibrahim.
Yes, Prof.
I think that this topic which we have delivered today
Right.
is an ever live topic.
Yes,
All teachers in across the world keep on struggling with this fact that how to ensure that students are attentive in the classroom.
exactly.
Students are paying attention in the classroom. What mechanism should be developed to judge that? I
Yes.
think quality teachers who have got experience are in a position to judge with different type of psychomotor factors which enables them to understand who is understanding and who is not.
Yes. Yes.
Otherwise, we normally interact with the students who keep on raising hands for everything and leave those students who do not take interest and thinking somewhere here and there.
Yes. That's true.
This challenge of retaining attention in the classroom will further increase the moment we are talking of now online and digital learning.
Yes.
And
Become very
particularly the
challenging.
kind of flipped classroom kind of environment where close to maybe around 70% plus lectures will shift online. The
That's
rest
right.
maybe around 20-30% maybe in face to face or maybe through interactive mechanism.
Yeah.
So this is an ever live topic which you have to keep on innovating and keep on finding that what method will suit best. I
Exactly.
think you will need to consult many of the domain experts as well.
Yeah.
So excellent. I have attended your almost all part of lecture, though it was a little technical, but it was
Yes,
a
I'm
very
fine.
useful for the people who wanted to do a cutting edge research. First, and the second, the kind of research which can be converted as a translational research and its value can be generated. If
Exactly.
few such good research papers are coming and outcome of those research papers go deeper into the classroom and the teachers start understanding the topic and start understanding the how which a student is taking interest and who is not,
Yes.
that probably will be of great value addition to this research, right?
Definitely. Definitely.
So thank you so much, and
You're most welcome.
a special thanks to you because today come full day you were packed and despite that you said yes to me and you were here delivered to our staff.
You're
Thank you
most
so
welcome.
much.
It was my pleasure. Thank you so much for inviting me.
It's my pleasure. It's my
Yeah,
pleasure.
I wish the best to you and to the whole team.
Oh yes, please. Yeah,
Okay,
Dr.
thank
Vishal.
you very much.
Yes, thank you, sir.
Thank you.
So much, sir, for
You're
giving
most
your
welcome.
valuable time. And it is a
You're most
great
welcome.
pleasure to have you in the 2 weeks refresher course. And if the participants would like to work with you in a collaboration, they will contact you as your email ID is mentioned on the first page of the slides.
That's
So
right.
I request to participants, if you would like to do work with the Professor Ibrahim, you can take his email ID and reply. He will reply you with your concern query. Thank
Exactly.
you
I will
so
be happy
much,
to do
sir.
so.
Yes,
Thank you
thank
so
you
much.
so much, sir. Thank
Thank
you
you.
so
Thank
much,
you.
sir.